Hello, my dear listener. Tonight, let's drift together through the quiet wonders of our planet, through the soft pulse of life that hums beneath every leaf, every wave, every breath. The world outside your window is still turning, but here, in this calm little corner, time can slow, and thoughts can float like dust in moonlight. Life on Earth is a tapestry of miracles, tiny ones, vast ones, some glowing in the deep sea, others blooming in silence on mountain air. From creatures that sleep frozen in ice, to forests that whisper beneath the soil, every form of life has found a way to endure, to create, to dream. Even now, while you rest, billions of hearts are beating, roots are stretching, tides are breathing in and out. You don't have to remember everything, just listen. Let each story flow like a lullaby made of science, a reminder that wonder doesn't have to be loud. It can be gentle, patient, and endlessly alive. If you enjoy these quiet journeys, you can softly tap like or subscribe, not for me, but to keep this little sanctuary open for every sleepy soul who wanders here. Now, take a slow breath. Feel your body sink a little deeper into the present moment. Outside, the stars are watching. Inside, your heartbeat hums with theirs. Let's begin our journey through the calm, extraordinary story of life on Earth. Far below the surface, where sunlight never wanders, the Earth whispers its oldest secrets. Down there, in the quiet crush of the deep ocean, chimneys of stone breathe clouds of scalding water, rich with minerals, heavy with heat, shimmering in the dark like underwater stars. It seems impossible that life could begin in such a place, and yet, perhaps it did. Long before trees, before rain, before even the sky we know, these vents may have been the first cradle of life. Inside their tiny mineral chambers, simple molecules drifted and met, drawn together by chemistry and chance. They may have joined hands in the darkness, forming the first delicate patterns of something that could grow, divide, remember, something that could become alive. The thought is humbling, isn't it? That everything, every heartbeat, every breath, every forest and ocean might trace back to a moment of warmth and pressure in a world without light. Even now, creatures still gather around those ancient vents. They do not need the sun. They live from the Earth's own heat, feeding on minerals instead of light. Their lives are silent, patient, and endless, like the heartbeat of the planet itself. So, as you breathe, imagine that pulse deep below, slow, steady, eternal. The same warmth that once kindled the first spark of life still hums beneath your feet. Imagine the world going still, rivers frozen, breath turning to silver mist, the air holding its quiet too tightly to move. Now imagine a tiny heart inside that silence, slowing, until it stops. No beat, no breath, no motion, and yet not death. In the forests of the north, the wood frog does exactly this. As winter deepens, it lets the cold take over. Ice creeps through its body, locking its veins, stilling its pulse. Inside, sugars bloom like a hidden warmth, wrapping each cell in protection, keeping it safe from shattering. Through the long months of snow, the frog lies frozen, a small, perfect statue of life, waiting in the dark. Then, one day, the thaw begins. The ice softens, the sugars flow, and the heart stirs again. Slowly, the frog awakens, stretching back into the world as though nothing had happened. Around it, other small creatures, insects, worms, tiny dreamers of the soil rise too, returning from their silent hibernations. It's a quiet miracle, life pausing itself without ending, as if the earth has given its children a gift, the power to stop time, to rest completely, and to begin again when the sun returns. And in that pause, in that frozen stillness, the rhythm of life never truly disappears. It simply waits for warmth, for movement, for the next breath of spring. Far beneath the waves, where sunlight has never touched, the ocean keeps its quiet secrets. Down there, the water is heavy and cold, the darkness endless, yet it is not empty. Out of the blackness rise pillars of stone, breathing clouds of warmth and chemicals into the still sea. Around them, life gathers. Blind crabs scuttle over glowing vents. Great tube worms unfurl like pale flowers, their blood-red plumes swaying in currents that never see the sky. Ghostly fish drift through the dark, feeding on the invisible rain of minerals and microbes. These creatures do not need sunlight. They are sustained by something older, a kind of deep earth alchemy, where bacteria draw life not from light, but from the breath of the planet itself. In this hidden world, energy comes from stone and fire, not from the sun. Whole ecosystems bloom in eternal night, their rhythm guided by chemistry instead of daylight. And far from the ocean, in caves beneath mountains, other beings live the same way. Their eyes have faded, no longer needed. Their senses of touch, vibration, and scent have become their light. A map written in feeling, not sight. It's strange and beautiful to realize that life does not fear the dark. It builds its own constellations there, silent, unseen, and utterly alive. Long before trees reached for the sky, before mountains wore their shapes, jellyfish were already drifting through the sea's soft, translucent ghosts moving with the tides of an ancient world. For over 500 million years, they have pulsed in silence, their delicate bodies untouched by time, their rhythms steady through cataclysm and calm alike. They have no bones, no heart, no brain. They are made almost entirely of water, yet somehow they endure. Their design is so simple, so perfect, that evolution has left it nearly unchanged. They move not by struggle but by surrender, letting the ocean carry them where it will, glowing faintly with their own inner light, a soft lantern in the deep. Sometimes they gather in great blooms, thousands upon thousands, floating like galaxies in slow motion, vast enough to be seen from space. Other times, a single jelly drifts alone, its pulse a whisper against the current. To watch one move is to look back through the ages, a living memory of Earth's earliest dreams. They are not relics of the past, but reminders that survival does not always come from strength or speed. Sometimes it is the art of being soft, the grace of simply floating through time. Beneath the surface of the world, in places where no sunlight ever falls, tiny lives are busy at work. There are creatures so small we cannot see them, and yet they are shaping the planet in ways that echo through time. Some of them eat light, some of them eat air, and some, the strangest of all, eat stone. They are called lithotrophs, a word that sounds almost like a spell. These microbes do not need plants, nor warmth, nor any of the foods we know. Instead, they draw their nourishment from the earth itself. They strip electrons from the minerals in iron and sulfur, and even from the heart of uranium, feeding on the quiet chemistry of the planet's crust. In the deep bedrock, far below the reach of sun or sea, entire colonies live like this, invisible miners, whispering among the stones. They move slowly, patient as the Earth's own heartbeat, transforming rock into energy and energy into life. Scientists believe they might be a glimpse of how life would look on other worlds, small, unshakable, surviving on nothing but dust and heat. Imagine that. Creatures who dine on mountains, who sip metal and sleep in the dark. Over billions of years, these unseen chemists have even changed the minerals they live within, leaving fingerprints across the ages. It may be that without them, Earth's chemistry and ours would never have become what it is. When you think of resilience, picture them, the silent eaters of stone, the patient ones who live in places no one else can, who remind us that life is not a surface thing. It grows wherever the faintest spark of possibility exists, even in the bones of the planet itself. Far to the north, beneath frozen seas, another kind of endurance takes root. In the quiet sway of the Arctic Ocean lives a forest without trees, vast meadows of seagrass that have been growing for more than 10,000 years. Each blade bends with the tide, glittering under pale light, part of a single ancient colony that stretches beyond imagination. On land, the same quiet persistence can be found in trembling groves of quaking aspen, like the Great Pando Forest in Utah. There, 40,000 stems rise from one ancient root, each trunk an echo of the same living being. Together, they breathe, shimmer, and age, not as individuals, but as a single, endless self. These elders of Earth measure time differently from us. They have witnessed ice ages, the wandering of continents, the rise and fall of civilizations. When you stand among them, the air feels thicker, slower, as if time itself has softened to their rhythm. They remind us that longevity is not only survival, but continuity, a life that flows, divides, and renews without end. The heartbeat of the earth, it seems, is counted not in years, but in the quiet breathing of forests and seas. Some trees hold a secret power that defies even death. When their branches touch the soil, they root. When their roots meet water, they grow new trunks. In this way, trees like the willow and the poplar clone themselves endlessly, spreading not through seeds, but through memory, a living network of renewal. The trembling giant of Utah, Pando, is perhaps the most astonishing of all. What appears to be a forest is in truth a single organism, 40,000 stems joined beneath the soil by one immense root. It is both mortal and immortal. Each trunk will fall, but the forest remains, reborn again and again through the patience of its roots. Standing among these trees is like standing inside a living echo. Their leaves shimmer in wind that feels ancient, as though whispering stories carried through centuries. Unlike animals, which pass and vanish, trees have found another way: to persist by replication, to pass life forward not by birth, but by extension. In this quiet persistence, they have found a kind of eternity, the art of spreading time across generations until death itself becomes part of renewal. Hidden beneath the forests, another life spreads even wider. In the Blue Mountains of Oregon lies one of the largest organisms on Earth, a fungus called Armillaria ostoyae. On the surface, it looks like scattered clusters of mushrooms sprouting after rain. But beneath the soil stretches a vast web of filaments, threads of life called mycelium, weaving for nearly 10 square kilometers, a living network older than empires. Each thread connects to roots, decomposing fallen wood, recycling the forest from within. It is at once destroyer and creator, feeding on death to nourish life. To walk across that forest is to tread upon a single being, a hidden giant that has watched the world change above it, silent and unbroken. It is both eerie and comforting to think that beneath our feet, An unseen mind of the forest is always at work, dissolving, rebuilding, breathing through soil. In that quiet labor, there is wisdom. Nothing is wasted. All things return, transformed. And while we look outward to the forests and oceans, we forget that within us, the same kind of community thrives. You are not just one being, you are a city. Inside your skin, in the curl of your intestines, behind your eyes and beneath your nails, billions of tiny lives hum in harmony. For every human cell, there are at least as many microbes, bacteria, fungi, archaea, each living, feeding, and communicating within you. Together they are called the microbiome, and they shape everything from your digestion to your mood. They protect you, feed you, teach your immune system when to fight and when to rest. Without them, you could not live. And yet, they ask for nothing more than a place to stay. You are their planet, their ocean, their forest of flesh and light. Every breath you take, every heartbeat, is a shared rhythm, a cooperative dance of countless beings moving as one. Life, it turns out, is never solitary. Even within ourselves, we are colonies of connection. There are creatures far smaller still and infinitely more resilient. The tardigrades, or water bears, are microscopic wanderers with 8 stumpy legs and faces like wrinkles frozen mid-smile. They live on moss, on seafloors, in the thin film of moisture between grains of soil, and yet they can survive almost anywhere. When the world becomes too harsh, they do something miraculous. They let go. They dry themselves to almost nothing, curling into tiny husks where no water, heat, or radiation can harm them. In this state, they are nearly timeless, their metabolism all but silent, their bodies preserved in stillness. Scientists have frozen them, boiled them, blasted them with cosmic rays, even sent them into the vacuum of space, and still they wake again as if nothing had happened. A drop of water, and life returns. Their secret lies in special proteins and sugars that shield their DNA, wrapping every cell in invisible armor. To the tardigrade, death is only a kind of waiting. They are proof that life can endure the impossible, and perhaps, somewhere beyond Earth, it already does. If such creatures exist here, what might be stirring on the silent stones of distant worlds? In the oceans, life bends its rules even further. Some fish are born one sex and become another. Among clownfish, the hierarchy is fluid. The largest in the group becomes female, while the others remain male. When she dies, the next in size transforms, reshaping its body and chemistry to take her place. In wrasses and groupers, the shift can move either way, male to female or female to male, depending on what the group needs to survive. Their bodies respond to social balance, rewriting themselves with astonishing grace. Hormones shift, organs transform, behaviors realign. What we think of as fixed, nature treats as fluid, a reminder that identity, even in biology, is not a single state, but a spectrum of change. Life does not cling to form. It adapts, rewriting its rules to continue the story. In the still waters of Mexico lives another miracle of renewal, the axolotl. With its soft smile and delicate gills that flutter like feathers, it looks like a creature drawn from dreams. But what makes it extraordinary is its power to rebuild itself. If an axolotl loses a limb, it grows back. If its heart is damaged, it mends. Even parts of its brain can return, perfectly formed, as though time itself reverses within it. Inside its tissues are cells that can become anything: skin, muscle, bone, rebuilding the missing piece with patient precision. Scientists study them, hoping to learn how such healing could one day be ours. But for the axolotl, it is simply living. Regeneration is not a miracle, but a rhythm, a gentle cycle of loss and return, woven into the calm waters it calls home. Perhaps, in some quiet corner of ourselves, that rhythm still exists too. Winter, for some, is not a season but a long breath held beneath the ice. Certain frogs, like the marsh frog, retreat into mud and silence, their lungs still, their hearts at rest. For months, they do not breathe as we do. Oxygen seeps gently through their skin, just enough to keep them dreaming. Their bodies slow to near stillness, metabolism hushed, time suspended. When warmth returns, they awaken, their voices rejoining the chorus of the thaw. It is patience in its purest form, survival through surrender. A lesson whispered by the earth that sometimes endurance is not about motion, but about stillness, about waiting until the world is kind again. Deep in the sea, a creature the size of a thumb can summon the power of the stars. The pistol shrimp, with its single oversized claw, snaps it shut so fast it creates a collapsing bubble, a tiny void that bursts with sound and heat hotter than the surface of the sun. The shockwave stuns its prey instantly. In the darkness, whole colonies of these shrimp crackle like underwater fires, their snaps echoing through the sea. From such small bodies, such enormous energy, a reminder that nature hides unimaginable strength in the quietest places. Every spark, every bubble, every burst of light beneath the waves is proof that even the smallest life can hold the force of creation itself. Far above, in the open skies, other mysteries unfold. Some birds, like the Arctic tern, can cross the world guided not by sight or stars alone, but by something deeper, the magnetic hum of the earth. Within their bodies lie tiny particles that sense the planet's field, turning them into living compasses. To them, magnetic currents may appear as faint lines of light stretching across the air, an invisible map that shows the way home. It is this quiet perception that allows birds to fly across continents, oceans, and endless sky, never losing their path. What to us is invisible is to them a world painted in direction. They remind us that there are senses beyond our knowing, ways of seeing shaped by silence and instinct, a dialogue between creature and planet written in magnetism itself. Every autumn, another traveler takes flight. Millions of monarch butterflies drift southward, their paper-thin wings shimmering like amber glass. From Canada to Mexico they go, following invisible currents across mountains and plains. None of them will return. It will be their great-grandchildren who complete the circle, guided by memories written not in mind, but in genes. How they find the same forests, the same trees, year after year, remains a mystery, a compass built into the soul of a wing. When a forest fills with their orange glow, it feels like standing inside a dream, a storm of color that breathes, rests, and moves with one mind, a reminder that migration is not just movement, but memory passed from generation to generation. Beneath the waves again, intelligence takes on other forms. The octopus, strange and graceful, carries 3 hearts and blood the color of moonlight. Its veins run blue with copper, perfect for the cold, oxygen-poor depths. 2 hearts feed its gills, the third feeds its body, and when it swims, that heart pauses as though even circulation must rest to make room for motion. It slips through crevices no larger than its eye, changes color and texture in a blink, and watches with an understanding that feels eerily familiar. To meet its gaze is to glimpse an alien consciousness, curious, cautious, and utterly unlike our own. There are minds in this world that do not think in words, yet they know the language of shape and light, of patience and play. Above the shore, a shadow flickers across the sky, a crow. Black feathers glint, eyes gleam with awareness. These birds are thinkers and rememberers. They can recognize faces, recall kindness and cruelty, even teach one another whom to trust and whom to avoid. Some humans who feed them receive small gifts in return: a coin, a shell, a button, tokens of gratitude from minds that understand more than we imagine. To watch a crow tilt its head is to feel the mirror of intelligence looking back. It asks quietly, "Who are you to me?" And in that question, we realize that thought itself wears many faces. Out at sea, beneath waves of light, dolphins glide in shimmering schools, weaving in perfect rhythm. They call to one another in distinct voices, whistles so unique that each becomes a name. Mothers sing to calves before they are even born, and the young carry those songs all their lives. When separated, they call each other's names across the water, a chorus of memory echoing through the deep. Their voices tell us that self-awareness, the knowing of one's own being, is not ours alone. Beneath the surface, life is speaking too. Across the savannas, another voice listens low, slow, and thunderous. Elephants, the gentle giants, can sense storms from hundreds of kilometers away. Their ears catch the low rumble of thunder that we cannot hear, and their feet feel the trembling of the ground. Through these whispers, they know when rain is coming. They begin their journeys before the clouds appear, leading their herds toward water. And as they move, they speak to one another in those same deep tones, voices that travel through the earth itself. Standing near an elephant is like standing beside the pulse of the planet, vast, calm, and wise. Beneath the blue expanse, whales sing songs that ripple through the oceans like ancient hymns. Their melodies change with time, shifting across years and seas as though the whole ocean shares a single, evolving song. Scientists still don't know why, perhaps to court, to call, or simply to create. Whatever the reason, the ocean becomes a cathedral of sound, each note a wave of memory passing from one generation to the next. Their songs remind us that culture is not ours alone. Music, too, belongs to the sea. And in the fading light of dusk, bats rise, silhouettes tracing the sky. While their cries map the dark through sound, they also see something we cannot: polarized light that lingers after sunset. To them, twilight is not an end, but a compass, a faint web of brightness that guides them home. Their world is layered with invisible geometry, the kind of beauty that hides from daylight eyes. Every swoop and turn is guided by unseen patterns, an artistry of flight beyond our sense. And somewhere, perhaps in a forest damp with morning, a strange golden organism spreads across the ground. Not plant, not animal, not quite fungus, a slime mold. It moves slowly, thoughtfully, its body a single enormous cell that stretches like a living thought. When faced with a maze, it finds the shortest path. When it encounters rhythm, it remembers it. With no brain, no neurons, it still learns. Its movement is a conversation between patience and pattern life, thinking without mind. It teaches us that intelligence is not confined to skulls or spines. It is a property of life itself, woven into motion, reaction, adaptation, a wisdom of being. In all of these stories, from the microbes that eat stone to the whales that sing across oceans, there is one quiet truth. Life endures. It shifts, adapts, pauses, renews. It grows in the dark, breathes through others, finds new forms when the old ones fade. The world is not simply alive, it is alive together. Every cell, every creature, every whisper of chemistry is part of a single, endless unfolding. And as you breathe now, slowly, softly, remember, you, too, are part of that unfolding. A thread in the great, luminous fabric of life, ancient, resilient, and still evolving beneath the same stars that once watched the first spark rise from stone. Beneath the soil, in the quiet dark where roots tangle and stones sleep, another kind of civilization hums. Long before humans learned to farm or build, ants were already practicing both. In endless processions, leaf-cutter ants march through forests, carrying emerald shards of leaves like tiny banners. Each fragment is precious, not as food, but as offering. Deep underground, the leaves are mulched, tended, softened by patient jaws, then laid gently upon the beds of their secret gardens. There, in warm and humid chambers, a pale fungus grows delicate, alive, and hungry. The ants feed it, and in return, it feeds them. Over millions of years, they have evolved together in a perfect loop of care. The fungus cannot live without the ants, and the ants cannot live without the fungus. Tiny farmers, invisible to most eyes, they even protect their crops with natural antibiotics secreted by symbiotic bacteria that live on their skin. What humankind learned in the last 10,000 years, they have known for tens of millions. Beneath every step we take lies an ancient agriculture, silent and thriving, a garden of cooperation older than civilization itself. And the gardens are only part of it. The colonies these ants build stretch wide and deep chambers upon chambers, linked by tunnels and highways, alive with motion. Millions of workers move in harmony, each carrying, tending, building. Some halls cradle the queen, who may live for decades, laying eggs that pulse with the future of the colony. Others serve as nurseries, storage vaults, and fungal farms, a living architecture of purpose and rhythm. To see their world through the eyes of a scientist is to glimpse order hidden in chaos. When mapped, these colonies resemble cities complete with divisions of labor, waste systems, and intricate communication. But here, the builders are blind. Their blueprints are instinct. Their tools are patience. The air is filled with scent trails, pheromone messages that flow like silent language, guiding every movement. Even larger architects dwell above them, the termites of Africa and Australia. On the blazing savannas, their mounds rise like earthen cathedrals, 6 meters tall, each grain of soil placed with precision. Inside, millions of termites farm their own fungi and breathe through walls that act like living lungs. The mounds inhale and exhale with the wind, balancing heat and cool, day and night. Their homes stay calm while the desert burns. Vents and chimneys regulate air and moisture so finely that even human architects have studied their designs, seeking to imitate such effortless harmony. If you stand beside one of these mounds at dusk, the air hums softly through its chambers, a sound like breath. You realize then that beneath the dust and heat, the earth is quietly alive with builders. Tiny minds, collective and tireless, shaping worlds grain by grain, the first architects of balance, hidden just below our feet. Deep in the ocean, after sunlight has surrendered to pressure and distance, life refuses to be invisible. Darkness, there is not emptiness, it is a canvas. Microscopic plankton wake in twinkling constellations. Whenever the water shivers, a galaxy shaken into being by fins. Transparent shrimp broadcast glittering code. Lures on anglerfish swing like cold lanterns, baiting curiosity into fatal nearness. Jellyfish pulse through the black with looping signatures, neon hoops, spirals, and curtains. Some detonate a burst of light that confuses hunters and buys an escape. Down here, light is bait, shield, message, courtship, and alarm. Some creatures keep a steady glow. Others fire strobe bursts so sudden they feel like underwater lightning. Sailors once feared milky seas. For the residents, radiance is grammar and choreography, the bright handwriting of survival. Even single-celled dinoflagellates create whole sea-wide glows called milky seas, a pale horizon-to-horizon haze. Sailors recorded long before scientists caught it in satellite images. The palette trends blue-green because seawater transmits those wavelengths best. But deeper down, there are rare rubies too, flashes of red reserved for close encounters. On muggy nights in river valleys and mountain coves, forests discover a heartbeat. Fireflies lift out of leaf shadow like airborne punctuation, each insect signaling on its own eccentric schedule, until, as if some unspoken treaty takes effect, the chaos tightens. Entire hillsides begin to blink in unison. Thousands pulse together, a woodland metronome striking the same luminous beat. The synchronization is not commanded, it emerges. Each beetle notices its neighbors and nudges its timing, and the pattern spreads outward until a grove inhales and exhales in gold. The purpose is pragmatic central casting for mates, but the spectacle feels metaphysical. Walking through such a grove is like entering a breathing cathedral where the choir sings with photons instead of voices. The mathematics behind the magic pops up in metronomes and heart cells. Local coupling can make a crowd behave like a single organism. For the beetles, it means their signals carry farther and stand out from background clutter, a broadcast tower built from bodies. We're spectators, but we are also lucky witnesses to biology, turning physics into romance. Offshore, squid practice vanishing and art built into their skin. 3 kinds of cells do the work. Chromatophores are expandable pigment sacs, living pixels that can appear or disappear in fractions of a second. Iridophores are microscopic reflectors that throw back iridescent blues and greens at whatever angle is useful. Leucophores scatter light into a soft fog that matches the neighborhood brightness. Working together, these tissues write patterns, stripes that race like wind over grass, rapid ripples that shout or soothe, and full-body camouflage that erases the animal against sand, rock, or open water. Some species scatter light so precisely that outlines melt, rendering the squid practically invisible. Others carry transparency like a philosophy, organs faintly visible, while the rest dissolves into sea. An ambush becomes easy when the hunter is a rumor instead of a shape. Their nervous systems are wired for speed. Patterns sweep across their flanks faster than a thought, a visual language that can scold rivals, woo mates, or hypnotize prey. Camouflage is not passive blending, but an active conversation with light, a real-time negotiation between appearance and environment that leaves cameras and predators equally baffled. Even ancient hunters carry soft lanterns. Lantern sharks and other species wear photophores in constellations across their skin, especially along the belly. When these organs glow, the fish are not showing off. They are canceling themselves, From below, an upward-looking predator expects a dim patch of skylight. By matching that pallid shine, a glowing shark erases its silhouette, an optical disappearing act called counter-illumination. The same light may double as a signal, a private channel for courtship or etiquette in the twilight zone. To imagine a shark that shimmers softly while it cruises is to admit the sea is not just a battlefield but a theater. Picture them as swimming constellations, star maps with teeth. Bioluminescence costs energy, which means the glow has to pay its way with reduced risk or improved mating odds. In the dim mid-water where shadows are rare and outlines betray, a little light buys secrecy. What reads to us as eerie reads to them as practical arithmetic. Time moves differently for the Greenland shark. Gray as weathered ice and unhurried as a glacier, it cruises cold North Atlantic depths with a patience that makes centuries feel domestic. Many harbor parasitic worms on their eyes, whitening the world to haze, but sight is optional when every motion is a negotiation with the deep. Radiocarbon dating of proteins in the lens has revealed individuals older than empires, animals that began life before telescopes showed Saturn's rings. Growth is slow, centimeter by centimeter, and sexual maturity may wait longer than a human lifetime. The recipe seems simple: cold, calm, and a metabolism tuned to thrift. Imagine swimming through dark water, while entire eras turn above you like pages in a book you never hurry to finish. The species biography mocks human impatience. A single life can overlap with the reigns of dozens of kings and the building and collapse of entire ports. They mature late, produce modestly, and drift through eras that would be history lessons to most creatures. Longevity here is not an achievement medal, but a side effect of a life lived slow. Under winter ice, lakes can run out of air. Most vertebrates cannot negotiate that deficit. Goldfish and crucian carp have a different arrangement. When oxygen drops to almost nothing, their metabolism takes a side road. Instead of drowning in lactic acid, as we do when our muscles go anaerobic, they convert sugars into ethanol. The alcohol diffuses safely through the gills into the water, sparing their cells from poison. It is not luxurious. Activity dwindles, growth stalls, and the fish wait like monks in a frozen cloister, but it works. Weeks can pass without oxygen, and when thaw returns, they resume ordinary life, as if emerging from a vow of silence. That biochemical switch is one of evolution's cheekier hacks. The pricing is right. Ethanol exits easily, while lactic acid would accumulate like debt. The fish endure sluggishly, but the line does not break. When oxygen returns, the metabolic detour closes, and the standard pathway hums again, as if winter were a parenthesis around ordinary life. Where drought is the dictator, lungfish vote for patience. These old-line vertebrates keep both gills and lungs, a dual passport they use to exit the crisis of a vanishing river. As mud hardens and channels fade, a lungfish burrows and secretes mucus that cures into a desiccation-resistant cocoon. Inside, it trims its budget dramatically. The metabolic books close, the heart idles, digestion pauses. A narrow tube to the surface acts as a snorkel for scant air. Months may pass, sometimes years. Rain finally remembers the old paths, and the fish softens its shell, wriggles free, and swims on as if a long paragraph has ended with a period. Estivation, the technical label for this suspended animation, borrows the patience of seeds. It turns a disaster into a delay. Inside the cocoon, tissues resist drying, proteins are protected, and the animal waits with the determination of a bookmark holding a place in a long novel. The rain, when it comes, is both rescuer and prologue. Eels built their biography out of secrecy. For centuries, no one could find their eggs. The solution, once stitched together, feels like folklore verified. European and American eels fatten in inland waters for years, then undergo a transformation. Bodies silver, eyes enlarge, and appetites change. They slip to sea and travel thousands of kilometers to the Sargasso, an oval of ocean bounded by currents rather than coasts and patched with free-floating sargassum. There, far from rivers and land, they spawn and die. Their leaf-like larvae drift back on currents, shrinking and reshaping until they become glass eels that nose their way into streams their parents never saw. An entire continental cycle runs through a place with no shores. The larvae are transparent leaves when they drift, then later become tiny eels, then stronger migrants nosing their way upstream past dams and weirs. Despite modern tracking tags and decades of study, the spawning itself remains largely hidden. The species keeps a sacred mystery, the exact choreography of life begun in a boundaryless sea. Night on a reef is risky, parrotfish answer with theater. Before sleep, many secrete a transparent cocoon of mucus that wraps the body like a shrink-wrapped blanket. To us, it looks like a magic trick. To a moray eel hunting by smell, it is a problem. The veil dampens scent, confusing the chemical trail that would otherwise betray a resting fish. It may also intercept parasites shopping for a midnight meal. At dawn, the cocoon splits and drifts away like shed cellophane, and the fish return to their day job, biting coral with beak-like teeth and turning reef architecture into the fine sand that builds tropical beaches. The habit looks outlandish, but has been independently invented by several parrotfish lineages, proof that a good trick gets copied. Experiments suggest these mucus tents can cut the odor footprint dramatically, turning a neon-colored fish into a rumor. Survival sometimes means sleeping in your own ghost. Seahorses arrange parenthood upside down. Courtship is a dance of careful postures and slow spirals, two animals rehearsing trust. Then the female threads eggs into a specialized pouch on the male's belly, and the roles invert. He fertilizes them internally and manages a pregnancy, supplying oxygen, regulating salts, and perhaps even selecting which nutrients to send. When gestation ends, his belly ripples with labor, and he ejects dozens, sometimes hundreds of miniature seahorses, tiny replicas that swim away at once. What many species spread between mother and father, the seahorse compresses into one remarkable male task. It also means females can produce the next clutch sooner because their energy is not trapped in brooding. The arrangement is a clever division of labor many social mammals would recognize, except here the cradle is built into a father's body. Watching the birth is surreal, a storm of tiny, perfect seahorses, and then stillness. To a water strider, a pond is not a boundary, but a floor. Its legs are long, lightweight, and furred with microscopic hairs that repel water and trap air, creating buoyant paths. Each step dimples the surface. Surface tension pushes back, an elastic trampoline of hydrogen bonds. The insect skates and pivots without breaking through, leaving a chain of dimples like footprints on a drum. Whole flotillas gather and move as if choreographed, riding reflected trees as scenery, while dragonflies patrol above and fish lurk below. The striders live between those worlds on a membrane that most creatures cannot use. The trick depends on physics that even a fingertip can feel. Dip a hand gently, and you see the meniscus climb your skin. That same cohesion holds the insect. Engineers study striders for inspiration in robot design, hoping to build machines that can inspect polluted ponds or glide where boats would be clumsy. Tardigrades, adorable under microscopes and nearly indestructible under everything else, treat catastrophe as a hobby. With 8 stubby legs and the vibe of a plush toy, they nevertheless survive extremes that shred DNA and desiccate cells. When conditions turn hostile, a tardigrade dehydrates into a ton. A compact capsule where metabolism nearly stops and protective proteins glass the interior. In this state, they shrug at years without water, tolerate vacuum, and endure radiation doses thousands of times higher than a human can stand. Add a drop of water and warmth, and the animal reanimates, resuming its tiny, patient errands as if nothing happened. Their resilience is not magic, but method sugars replaced, water hidden away, DNA wrapped in protective scaffolds, antioxidants standing by like a fire brigade. Space agencies have mailed them into orbit, not because they are cute, but because they are sturdy couriers, carrying lessons about what life might endure beyond Earth. Some photosynthesizers choose a home address inside stone. In Antarctica's dry valleys and in the Atacama Desert, certain algae occupy the translucent margins within rocks, a few millimeters below the surface. The stone acts as both sunscreen and greenhouse, filtering harsh ultraviolet and wild temperature swings while admitting a ration of light sufficient for photosynthesis. Water arrives stingily. Frost, melt, dew, or capillary seep through mineral pores. Life slows to match the budget. These endolithic communities survive where the surface is uninhabitable, and they expand our imagination about what worlds beyond Earth might quietly host. Astrobiologists take notes. If algae can survive tucked under a few millimeters of quartz in a polar desert, then Mars or the moons of the outer planets start to look less implausible as homes for modest life. Endoliths show that habitability is not a uniform blanket, it is a mosaic, and some tiles are very small. Lichens look like smudges of crust or fans of lace, but they are partnerships wearing a single cloak. A fungus, the mycobiont, builds lodgings and routes mineral traffic. An alga or cyanobacterium, the photobiont, pays rent in sugars minted from sunlight. Together they act like pioneer organisms, colonizing bare rock, etching weak organic acids that loosen nutrients, and slowly converting stone to the first thin films of soil. Their tolerance is legendary. They desiccate to dormancy in hours and revive within minutes. Pigments and antioxidants blunt ultraviolet. Dense mats buffer frost and heat. Many grow only millimeters a year, yet persist for centuries, some likely far longer, painting cliffs with quiet color while whole bird colonies come and go. They propagate by sending out Soredia and Isidia, tiny pre-packaged teams of fungus plus photobiont, so the partnership spreads intact. Because they absorb from air and rain rather than roots, they record pollution like ledgers, accumulating metals and acid mists as chemical diaries of air quality. Where nothing else grows, lichens begin possibility, stabilizing dust, trapping moisture, and laying the groundwork for mosses, herbs, and eventually forests. Their thesis is simple and durable: cooperation over speed, tenure over spectacle. Add precision without drift. Lichen bodies come in 3 efficient forms: crustose, painted on crusts that grip rock; foliose, leafy lobes that lift and vent moisture; and fruticose, upright or hair-like branches that maximize light. A cortex shields, a photobiont layer earns, a medulla ventilates, and rhizines anchor 4 layers, one machine. Reproduction splits into two lanes: asexual fragments, fast colonizers, and sexual fungal spores, slow scouts that must recapture a compatible alga in the wild, a built-in test of conditions. On volcanic lava, in alpine scree, and in deserts as biological soil crusts, they lock loose grains together and kickstart succession. Growth is slow by design. Longevity is the payoff. In sediment, where oxygen never arrives, bacteria still close their metabolic accounts. They breathe metals as terminal electronic receptors, Phe3 to Phe3, MinDiV to MinDiV, even UV down to insoluble UIV. The swap paints grains with rust skins, shifts groundwater chemistry, and sets redox fronts that creep through mud. Genera like Geobacter and Shewanella export electrons via C-type cytochromes and conductive pili microbial nanowires, moving charge to minerals centimeters away. Cable bacteria couple sulfide oxidation deep below to oxygen reduction at the surface, turning the seafloor into a living circuit. Same physics, different outcomes. Contaminants can be immobilized, useful, or mobilized. Hazard, so context matters. The redox ladder is orderly. Oxygen first if present, then nitrate, manganese, iron, sulfate, finally CO2 to methane each step, yielding less energy but keeping metabolism alive. What looks like dull mud is a stack of tiny batteries, electrons hopping from food to rock, geology and biology merging into one process. Humanity's favorite material, turned nuisance plastic, has started to find a niche in biology, reluctantly, at microbial speed. Certain bacteria and fungi secrete enzymes that unzip long polymers into digestible monomers. Ideonella sakaiensis wields a PE-tasum headase relay that turns PET into terephthalic acid and ethylene glycol. Engineered cutinases, like fast pedicase variants, push rates higher by stabilizing active sites at moderate temperatures. Biofilms help, roughening plastic and trapping enzymes where they're needed. UV and heat pre-crack chains, giving biology purchase. Limits remain: crystallinity, additives, and mixed streams slow breakdown. That's why the tight strategy is hybrid: mechanically sort and shred, chemically depolymerize tough fractions, and let tuned enzymes finish the job, so monomers re-enter manufacturing at full quality. Pair that with polymers designed for end-of-life, PHAs, that microbes already read, and the loop tightens. The goal isn't absolution, it's conversion waste as feedstock, not forever litter. Beneath a forest, an internet hums without wires. Fungal hyphae lace soil and braid into roots, forming mycorrhizal networks that haul goods and gossip. In arbuscular systems, fungi build arbuscules inside root cells to trade phosphorus and water for plant sugars. In ectomycorrhizae, sheaths wrap roots and radiate outward, mining nitrogen and moisture. Most plants, nearly all herbaceous species, and a majority of trees plug into one or both systems. Isotope tracers show carbon moving from sunlit crowns to shaded seedlings. Nutrients flow back as rent. Defensive signals ride the same threads. The ledger has rules. Kin often receive better terms. Chronic freeloaders see the tap tighten. During drought, hyphae bridge dry gaps, keep aggregates stable, and shuttle limited water. After disturbance, surviving networks map which species rebound first. From below, a forest is logistics plus rumor, supply chain, social graph, and hazard alert built from living cables. Plants conduct aerial diplomacy as well. Under attack, leaves synthesize volatile cues, green leaf volatiles, methyl jasminate, methyl salicylate that drift to neighbors. Kin prime defenses, boosting bitter metabolites and toughening tissues before the herbivore arrives. Some species escalate by summoning allies, maize and cotton release bouquets that recruit parasitic wasps to caterpillars, beans call predatory mites to spider mites. Signals also move underground via root exudates and mycorrhizal highways, extending the conversation beyond wind direction. The split is disciplined, not diffuse. Jasminate-leaning pathways counter chewing insects. Salicylate-leaning pathways counter pathogens. Two-dials plants adjust with minimal waste. Farmers fold these rules into practice. Companion plants that broadcast helpful volatiles, cultivars selected for strong priming, and reduced pesticide loads where biology can do the messaging. Taken together, these stories sketch a crisp worldview. Life is a library of experiments, not a ladder. Cooperation is a tool, not a slogan. Fungus with alga, root with hypha, microbe with mineral. Energy moves as electrons and light. Information moves as molecules and threads. Designs favor modular parts, redundancy, slow growth when the payoff is tenure, speed only where it compounds. Metabolism adapts when oxygen or water leave the script. Bodies switch materials when transparency, elasticity, or armor is required. Even our synthetic leftovers become solvable puzzles once we align chemistry with biology. The instruction is practical. Observe closely, test assumptions, and look for function in the strange. Curiosity maps the route, skepticism keeps the footing, and wonder reminds us to notice how much the world already knows how to do. The Venus flytrap practices arithmetic without a brain. Along the inner surface of each trap sit delicate trigger hairs wired to a timing system. One brush is noise. Two touches within roughly 20 seconds confirm a visitor worth catching. Only then do the jaws hinge shut, spines interlock, and a living vault seals. Subsequent movements by the captive prompt secretions, digestive cocktails that dissolve muscle and cuticle into a nutrient soup. Counting buys efficiency. The plant spends energy only when a genuine meal is present. Watching a trap close feels like witnessing thought in chlorophyll stillness turning into strategy, precision expressed in green. Plants, it turns out, can remember. The sensitive plant, Mimosa pudica, folds its leaves at the slightest insult. In a classic experiment, potted mimosa were gently dropped a short distance, again and again, with no damage done. Early trials sent leaves snapping shut. Repetition taught the opposite. The plants stopped responding to a stimulus that proved harmless. Weeks later, long after the last drop, they still ignored that particular jostle, yet folded instantly when presented with something new. No neurons are involved. Memory lives in shifts of biochemistry, ion channels and signaling pathways that recalibrate sensitivity. Rooted bodies, yes, yet not oblivious. They register, experience, and treat the future differently because of it. Bamboo is speed wearing leaves. Certain species, given warmth, water, and rich soil, can add nearly a meter of height in a day, the botanical equivalent of a rocket launch. Its hollow, segmented stems act like highways for water and dissolved minerals, pushing growth to the tip of each culm with ruthless efficiency. Humanity has noticed. Floors, flutes, scaffolding, ladders, chopsticks, paper, food cultures, across Asia and beyond, have learned to live with and from bamboo. Forest trees tally decades before replacing themselves. A harvested bamboo grove answers within a season. Flexibility is its strength, resilience its signature, velocity its poetry. Deep in Sumatra, a plant rehearses spectacle. The Titan arum, nicknamed the corpse flower, saves its strength for rare eruptions. When it commits, a towering spadix rises from a frilled cone of flesh, often taller than a person, and sometimes more than 3 meters high. For a few fevered days, the plant heats itself and vents an aroma that impersonates carrion. Flies and beetles arrive, duped by the chemistry of death, and accomplish the plant's business by moving pollen from one titan to another. The bloom is equal parts cathedral and prank, exquisite color and architecture wrapped around a perfume that makes visitors recoil. The show ends abruptly. The spire collapses. Years pass. Then the rainforest rehearses the trick again. Orchids prefer theater. Some species forged the ultimate perfume and form tuned to mimic a female insect. Petals become convincing silhouettes. Their surfaces exhale the right pheromone blend. Males attempt to mate with the flower, are dusted with pollinia, and then repeat the mistake on another blossom. Beauty, here, is bait. It is survival written as illusion, seduction perfected by natural selection. If the corpse flower needs a second introduction, it earns it. When botanical gardens announce a bloom, people queue through the night, drawn as much by curiosity as by the myth of the smell. The odor is a fresco of volatile chemicals, sulfur and funk, layered into a convincing imitation of rot. The goal is not morbid theater, but targeted advertising to the right insects at the right hour. For the plant, disgust is a delivery service. Seeds make time travel ordinary. A seed is a vault of instructions, desiccation tolerance, and insurance against bad years. Some vaults are astonishingly durable. In Siberian permafrost, botanists persuaded a plant to wake from a seed older than recorded history. In the Judean desert, ancient date palm seeds produced modern leaves under modern sun. Metabolism slows to a whisper. Protective sugars glass the interior. DNA rests wrapped and guarded. A dry, dusty speck can hold a forest in escrow. Mangroves solve salinity by editing water at the door. These coastal trees colonize the slosh zone where tides complicate every day. Some species strain salt from seawater as it enters the root. Others let brine through and ship excess sodium and chloride to leaves, where specialized glands excrete crystals. Above-ground prop roots buttress trunks against waves and trap sediment, nursing fish nurseries and crab neighborhoods in the tangle. These groves stitch shorelines together, buffers against storms, engines of productivity, green barricades that turn turbulence into habitat. Grasslands burn, then breathe again. Fire races through a prairie, licking dry stalks to ash. Underground, the story is different. Rhizomes, bulbs, and basal meristems lie insulated in soil, asleep but unscathed. When rain follows fire, tender shoots push into a blank canvas. Grazers arrive to harvest the flush. The system resets its clock. Many savannas and prairies expect fire. Some require it. Flames are not only catastrophe, but maintenance. Clearing dead thatch, returning minerals, making room. Coral reefs, cathedrals carved by tiny hands, arise from the work of polyps, small relatives of jellyfish that secrete limestone cups and live by day with algae roommates. Over centuries, the cups pile into ridges, buttresses, shelves, and labyrinths. A quarter of all marine species use this architecture for food or refuge. Waves lose their teeth against reef walls. Coastlines thank them silently. Space photos of bright rings in shallow seas record a fact easy to forget under a snorkel. Reefs are cities built slowly by minute masons who never stop. Clownfish rent rooms in danger and pay their keep. Sea anemones wield venomous threads that sting anything that blunders into their tentacles. Clownfish coat themselves in a custom mucus and move in without consequence. The fish chase nibblers, fan fresh water through tentacles, and drag crumbs home. The anemone supplies armor. The fish provide security and housekeeping. Few residents stray far. The world is full of partnerships. This one is unmissable. Bright orange darting among waving white, purple, or green arms. Reefs host service economies too. Cleaner wrasses and other species establish stations where larger fish queue with manners rare elsewhere. Groupers flare gills, moray eels open mouths, parrotfish hover, and the cleaners go to work, picking parasites and dead tissue. Even predators play nice while the appointment lasts. Food for the cleaners, relief for the clients, a handshake coded into behavior. Cooperation breaks out in a place famous for competition. Some sharks never stop moving because stillness suffocates. Ram ventilators, great whites and makos among them, must keep water moving across gill filaments to harvest oxygen. Their rest is a partial shutting down of brain activity while the body continues its pilgrimage. To watch telemetry traces is to glimpse a life built on perpetual motion, sleep braided into glide. Hatchling sea turtles enroll in astronomy the minute they leave sand. A nest hatches. Dozens of tiny reptiles scramble toward the brightest horizon, usually star and moonlit waves. As adults, they cross basins and navigate back to ancestral beaches, likely blending magnetic information with celestial cues. On dark nights and clear water, light is a compass older than compasses. Penguins turn the ocean into a drinking fountain. Salt glands above the eyes pull sodium chloride from the blood and discharge it in concentrated drips and sneezes. The adaptation liberates them from freshwater sources in an icy world where liquid water is a luxury. Biology solves a chemistry problem. A bird solves an ecology problem. A colony thrives. Some birds nap with one hemisphere of the brain at a time. Great frigate birds cruise tropical skies for days, months even, without landing at sea. Electrodes reveal brief episodes of unihemispheric sleep. One side of the brain powers down, while the other mines the wing and the world. Seconds accumulate into meaningful rest, and the voyage continues. Albatrosses write poems in wind. 3+ meter wings lock like sail spars as the bird executes dynamic soaring tacking between layers of air moving at different speeds. By harvesting energy from wind shear, they can go hours without a flap, arching across wave crests as if the planet itself had become a treadmill. The itinerary: ocean, 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 nest, ocean. Hummingbirds compress a furnace into a featherweight. Wing beats blur. Hearts sprint past 1,000 beats per minute in flight. Metabolism burns hot enough to require constant nectar stops. Night rewrites those rules. The bird enters torpor, a controlled cool-down that preserves its tiny fuel tank. In migration, some cross the Gulf of Mexico in a single leap, a bright spark propelled by stored sugar and precise timing. Courtship sometimes becomes choreography. Birds of paradise rake forest floors into spotless stages, then transform. Feathers flip, iridescent shields flare. Tails become frames and circles and lines that seem more crafted than grown. Females scrutinize the show, not just color, but coordination, stamina, and novelty. On lakes, grebes dash side by side, feet drumming the water surface in duet. Performance is honest advertisement, beauty, a dossier of health. Lyrebirds are sound archivists with feathers. These Australian virtuosos stitch the forest's noises, other birds, rusted hinges, camera shutters, chainsaws, into a single, seamless performance. Their mimicry is so faithful that a listener can be tricked into believing an unseen machine is running. The tail's ornate lyre is a bonus. The voice is the headline. The Arctic tern chases summer around the planet. Breeding in the high north, it then arcs to Antarctica and back, logging tens of thousands of kilometers annually. 2 summers per year, more daylight than any other vertebrate, a life measured not in seasons but in circles. Spiders master flight without wings. Spiderlings climb a twig, raise abdomens, and release silk fine enough to be seized by electric charges and breezes. Ballooning lofts them across fields, over forests, sometimes into the lower atmosphere, where they drift like dust motes. Ships hundreds of kilometers offshore have recorded their arrival. Threads of spider silk bind continents in quiet, aerial migrations. Other spiders build architecture. Orb weavers throw guy lines, trace radial spokes, and then spiral a sticky capture silk that can stop insects much larger than the builder. Spider silk is a materials scientist's riddle, light, elastic, and stronger gram for gram than steel. A web is not a net thrown randomly. It is geometry, placed precisely where traffic will be thick at dawn. Some arachnids choose engineering over net casting. Trapdoor spiders dig silk-lined burrows, then construct camouflaged lids hinged with silk. They wait inside, fingers on tripwires, and rocket upward when the threads vibrate. The door slaps shut behind a retreating hunter. No scenery, all drama. Parasitic wasps write horror that works. A sting places an egg into a caterpillar. The larva feeds, avoiding vital organs, and releases chemicals that alter the host's behavior. One species turns a cockroach docile and leads it, puppet-like, to a nursery where the roach will be food. Another drafts a caterpillar into sentry duty, guarding wasp cocoons even as it dies. Evolution will use any tool on the shelf, including minds. Honeybees communicate with trigonometry and rhythm. A forager returns, shivers into a figure 8, and runs the straight waggle segment at a particular angle. That angle tells followers where the flower patch lies relative to the sun. The vigor and duration hint at distance and quality. The dance updates through the day as the sun's position changes. A hive looks like chaos. It behaves like consensus. Frogs can be couriers and parents. In Central and South America, strawberry, poison, dart frogs, fairy tadpoles piggyback up tree trunks to water-holding leaves. The mother returns with unfertilized eggs to feed each youngster, a case of maternal provisioning, rare among amphibians. One by one, puddles become nurseries. The Suriname toad turns skin into cradle. After mating, eggs press into the female's back. Her skin grows into a honeycomb that shelters them. Weeks later, tiny toads erupt from individual pockets like kernels popping. The sight unsettles. The strategy succeeds. Glass frogs carry translucence like armor. Many species in cloud forests present clear bellies through which heart and gut are visible. Against a mosaic of leaf-filtered light, transparency reduces outline and recognition. Anatomy becomes camouflage. Fragility becomes advantage. Horned lizards weaponize surprise. Cornered by a coyote or fox, they increase blood pressure in vessels around the eye until a small jet of blood arcs outward. The fluid tastes awful to canids. The display startles. Spines and sandy tones do the rest. Elegance is optional. Effectiveness is mandatory. A basilisk lizard sprints across a stream by slapping the surface hard and fast. Fringed toes trap pockets of air. Rapid strides prevent sinking until momentum wanes. Juveniles, lighter and springier, can run farther than adults. Physics, not miracles, holds them up, but the first time you see one, wonder wins. Southeast Asia's paradise tree snakes launch from branches as ribbons that glide. By flattening their bodies and rippling midair, they generate lift and steer with accuracy that seems to defy classification. No wings, yet flight. No feathers, yet control. Komodo dragons wield more than serrated teeth. Venom glands lace their bite with compounds that lower blood pressure, prevent clotting, and induce shock. A struck deer can flee and still lose the race hours later. The lizard follows the chemical breadcrumb trail at a patient, prehistoric pace. Crocodiles slow time. Their hearts can idle to a handful of beats per minute. Their metabolism purrs so low they can skip meals for weeks. Buried in mud or lurking in tannin-dark pools, they wait until timing tilts in their favor. 200 million years of refinement have perfected patience. In dark rivers, some fish speak in electricity. Knifefish and elephant nose fish generate weak fields around their bodies with electric organs. Distortions in that field map the world without light. Modulations in frequency and pattern carry messages. Each species sings a different waveform. Each individual has a signature. The water, silent to our ears, hums with conversations we cannot hear. Electric eels turn voltage into weapon. Special cells called electrocytes, stacked like batteries, fire in synchronized waves to deliver shocks strong enough to stun large predators and prey. Weaker pulses map the murk. Heavy artillery ends arguments. Indigenous fishers knew their power long before labs measured it. Many deep-sea fish borrow their glow from bacteria. Photophores, specialized light organs, house microbial tenants that shine in steady blues and greens. Some fish dim silhouettes against down-welling light so hunters below see nothing. Others blink patterns to coordinate schooling or to lure small prey. The arrangement is fair. Nutrients and safe housing for the microbes, light on demand for the host. Squid use skin as screen and sentence. Chromatophores open and close. Iridophores reflect and leucophores diffuse, producing crackling color changes across the mantle. Individuals can camouflage. Groups sometimes pulse in coordinated patterns that look like conversations, courtship, intimidation, cooperation. To human eyes, it reads as neon. To a squid, it is grammar. Vampire squid haunt oxygen-poor layers where most animals suffocate. Gelatinous bodies reduce energy costs. Filaments collect marine snow, flakes of organic debris drifting down from brighter worlds. The animal's name comes from a cape-like web and dusky color, not from blood. It is less villain than monk. Low demand, patient, persistent. Colossal squids look back with dinner plate eyes. 30-centimeter orbs capture faint cues in Antarctic dark, bioluminescent flickers, whale shadows. The eye size tells a story about scarcity. Information is rare down there, so you build the largest detectors you can. Barrel-eye fish hide a pair of swiveling tubes inside a transparent, fluid-filled head. Upward-pointing eyes watch silhouettes above. When prey drifts close, the eyes rotate forward to track the approach. The dome protects sensitive tissue from stinging tentacles that festoon deep-sea drifters. Anatomy becomes periscope. Skull becomes skylight. Anglerfish dangle a living lamp above an abyssal mouth. Bacteria in the lure handle the lighting. The fish handles the trap. Many species feature minuscule males that fuse permanently to large females, donating sperm in exchange for a seat on a reliable life support system. Collateral moral: in the deep, light is currency and cleverness. Decorator crabs wear the reef. They tuck snippets of sponge and sprigs of hydroid into hooked hairs on their shells, breaking the telltale outline that would betray them to hunters. Sometimes they pick bodyguards, anemones that sting would-be diners. The anemone gets transport to fresh hunting grounds. The crab gets a booby-trapped hat. Fashion meets function. Hermit crabs run housing markets. A newly available shell attracts a crowd. If the shell is too big for most, the gathering can organize into a size-sorted queue. One by one, each crab trades up into the vacated home of the neighbor ahead. The result feels like an apartment swap meet, executed with surprising politeness. Mantis shrimp see a world painted with wavelengths we can't imagine. Up to 16 types of photoreceptors to R3. Ultraviolet patterns blaze from shells. Polarized reflections carry hidden signals. Their second superpower is kinetic, a spring-loaded strike that accelerates so quickly it boils water locally and creates collapsing bubbles whose shock adds a second hit. Glass breaks, snail armor splinters, a reef gladiator wins. Even worms write with light. Polychaetes disturbed in the twilight mid-waters exhale sparks and dust the water with green luminescence. The glow may confuse attackers or signal mates. To human eyes, it looks like a comet unspooling a tail, then fading to black. On the seafloor, geology and chemistry assemble towers. Hydrothermal vents expel superheated, mineral-rich water into cold ocean. Metals precipitate and build chimneys. Black smokers with smoky plumes and paler variants with different chemistry. Around them, instead of sunlit photosynthesis, life runs on chemosynthesis. Bacteria harvest energy from hydrogen sulfide and other chemicals. Macrofauna dine on or house those bacteria. An entire city blooms in night. Heat that scalds our skin is a warm bath for thermophiles. In boiling springs and steaming runoff channels, bacteria and archaea run enzymes built for hot work. Their pigments paint the pools orange and gold. A few tiny animals manage to live in the margins. The lesson is not bravado, it's breadth. Life stretches to fill niches that look like nightmares to us. Acid lakes do not end the story. In places where pH slips toward zero acid mine drainage, volcanic calderas, Dalol-style hydrothermal pools, microbes keep cytoplasm near neutral, while the outside is essentially liquid sandpaper. They do it with membranes packed tight against proton leak. Archaea favor ether-linked lipids, and at extremes, monolayer tetraethers. With powerful proton pumps and Na-mice, H-mice antiporters that throw excess H-mice back out, and with cytosolic buffers that mop up what gets in. Proteins are engineered for acid, extra salt bridges, and compact folds that resist unfolding. Chaperones refit damaged enzymes. DNA-binding proteins and polyamines stabilize the genome. Energy comes from bold chemistry. Iron and sulfur oxidizers, for example acidithiobacillus, leptospirillum, Strip electrons from Fe squared Mi, or reduced sulfur, and hand them to oxygen, precipitating ferric iron, yarosite, and other vivid minerals that paint pools red, orange, and yellow. Some species run reverse proton gradients, letting the outside acidity power ATP synthase in unusual ways, while heterotrophs graze on the biomass of the chemolitho-autotrophs. Biofilms cement grains, trap metals, and create micro-niches a few micrometers wide, with slightly kinder pH. These systems are natural laboratories for metal cycling and bioremediation. They immobilize contaminants in some settings and mobilize them in others. If cells can defend neutral cytoplasm in near-battery acid here, subsurface brines on Mars, or perchlorate-laced films on its salts look less implausible. Acidophiles widen the search window for life by proving that solvent and habitable are engineering problems, not showstoppers. Miles below the surface, rock itself hosts life. Water threads through fractures and nanopores. Pressure climbs past 1,000 atmospheres. Sunlight never arrives. Microbes live on gradients born of geology. Hydrogen from serpentinization, water plus olivine. Radiolytic hydrogen from natural radioactivity splitting water films, sulfate-sulfide shuttles in sediment, and CO2 reduced to methane by methanogens. Many cells are ultra-sparse, attached to mineral faces, dividing so slowly a generation can span centuries. Biomass turns over on geological time. Temperature pushes the upper limit of life toward to 120 degrees Celsius in some boreholes. Pressure-tolerant enzymes and rigidified membranes keep proteins in working shape. Communities include sulfate reducers, methanogens, iron and manganese cyclers, and organisms that fix carbon without light, running Calvin or reverse TCA pathways on rock-fed electrons. Isotopic fingerprints and carbonates, dissolved gases, and pyrite layers mark metabolisms that have pulsed for millions of years. Planetarily speaking, the deep biosphere rivals surface oceans in volume of habitat, reminding us Earth is not merely alive at the skin, but hums through its crust, an ecosystem wired by cracks, fueled by stone, and throttled by diffusion. At vents, sulfur becomes bread. Along mid-ocean ridges and back-arc basins, 350 degrees Celsius vent fluids, rich in H2S, H2 Fe squared Mies, and CH4, meet near freezing seawater. Steep chemical gradients bloom. Giant tube worms, Riftia pacatilla, host sulfide oxidizing gamma proteobacteria in a trophosome, no mouth, no gut. The worm's crimson plume houses specialized hemoglobins that bind oxygen and sulfide simultaneously without self-poisoning. Circulatory plumbing delivers both to the symbionts, which oxidize sulfide via SOx and related pathways. Fix CO2 Calvin cycle, or RTCA, and hand carbohydrates and amino acids back to the host. Mussels, Bathymodiolus, and snails, Alviniconcha, run similar deals, sometimes with methane oxidizers instead, sulfur or methane as bread, depending on the vent. Immune systems are tuned to tolerate resident bacteria while resisting opportunists. Hosts regulate symbiont load by oxygen and sulfide supply. Even the architecture of chimneys' porous sulfide walls with micron-scale channels sets reaction geometry for the microbes living within. What looks alien is an alternative photosynthesis. Electrons from the Earth instead of the Sun, oxygen or nitrate, as acceptor where available, biomass as the outcome. Collectively, extremophiles erase boundaries we drew around life. Boiling springs, thermophiles, with heat-hardened proteins and membrane lipids, ice that never thaws, psychrophiles with flexible enzymes and antifreeze proteins, pressures that flatten submersibles, piezophiles with pressure-proof folding, radiation that shreds DNA, Deinococcus with repair swarms and chromosome copies, salts that desiccate halophiles using K-mice-rich cytoplasm and acidic proteins, acids that etch metal acidophiles with proton-tight membranes, alkalinity that curdles proteins, alkaliphiles running sodium circuits. Someone is there, dividing. Each discovery on Earth extends the address book for plausible biology. Martian subsurface brines, fueled by radiolytic H2. Europa's dark ocean, where serpentinization and tidal energy could feed chemolitho-autotrophs. Enceladus, whose plumes already carry H2 and organics. Titan, where cryochemistry might favor membranes of a different kind. We're not guessing wildly, we're extrapolating from a library of proven weird. Step back, and a pattern emerges. Light turns into language, weapon, and veil. Electrons into currency, gradients into paychecks. Movement becomes sleep and map, stillness a long-term strategy. Partnerships plant with fungus, fish with anemone, worm with bacteria, deliver functions nobody could build alone. Bodies hack gravity and surface tension. Chemistry becomes sense, and sense becomes story. Nature is not a museum of finished sculptures, but a workshop of prototypes under continuous test. The honest posture is curiosity yoked to skepticism. Observe, measure, try to break the idea, keep the wonder intact. The game is ongoing. The deck has wild cards. Birds are dinosaurs with feathers and an airplan. A robin on a fence or a hawk spiraling a thermal is a theropod in modern kit. Feathers preceded flight, simple filaments, stage I, to branched plumes with veins and interlocking barbules, stage 4V, first for insulation and display, then for aerodynamic control and finally powered flapping. Skeletons retain family signatures, hollow, air sac-pierced bones, a furcula, wishbone, acting as a spring, a semi-lunate carpal that permits the wing's folding stroke, a keeled sternum for flight muscle anchor, a pygostyle for tail feather control. Lungs are a cross-current exchanger with unidirectional flow and multiple air sacs, posterior and anterior, acting as bellows high-efficiency gear inherited from non-avian theropods. Brooding postures appear in fossils. Medullary bone, a calcium reserve for eggs, shows up in a T-Rex specimen. Melanosomes trapped in feathers reveal color patterns. When a wren sings, deep time is speaking in present tense. The dynasty never died, it grew wings. If birds are reinvention, crocodiles are the master class in sticking the landing. For is greater than 200 mere. Crocodilians have edited commas, not paragraphs. Their chassis, low-slung, semi-aquatic, osteoderms as armor plates, pairs with a four-chambered heart featuring the foramen of Panizza and a controllable right-to-left shunt that routes blood during diving or digestion. They throttle heart rate to a handful of beats per minute, bask to manage temperature, and ambush with explosive acceleration. Integumentary sensory organs dot scales. They detect ripples from prey. Parental care is robust, guarding nests, assisting hatchlings, and social vocalizations tuned to context. Temperature-dependent sex determination links climate to demography. Some lineages evolved salt glands for marine living. Others refined longarostri for fish spearing. Change happens, but the core design works so well that selection mostly fine-tunes. Some fish hold dual passports. Lungfish, dipnoi, switch between gills and true lungs, homologous with our own. In Africa and South America, they estivate when ponds vanish, burrow, secrete a mucus cocoon, downshift metabolism by an order of magnitude, switch nitrogen waste from ammonia to urea to spare tissues, and breathe through a narrow air chimney for months to years. Hemoglobin shifts, improve oxygen loading at low O2. Surfactant keeps lung alveoli open. Gene expression rewires proteolysis up for muscle fuel. Water channels down to conserve fluid. Oxidative damage defenses up to ride out the drought. Evolutionarily, they're paired fins with robust internal bones. Their lungs and their circulation offer a living window into the fish to tetrapod transition, the air-breathing experiment that stuck. The ocean's giants began as landwalkers. Early whales chart a clean fossil sequence. Pachycetus, terrestrial, inner ear involucrum, already cetacean-like. Ambulocetus, amphibious, walking whale. Remingtonocetids and protocetids, coastal swimmers with hind limbs still functional. And Basilosaurus, Dorudon fully aquatic, hind limbs reduced to vestiges, fluked tails. The telltale double pulley astragalus in ankles ties them to artiodactyls, even-toed ungulates, think hippos, as close living kin. Nostrils telescope backward into blowholes. Skull bones telescope for streamlining. Ear bones isolate for underwater hearing. Later, Odontocetes, toothed whales, evolve echolocation, tuning high-charge myoglobin and specialized nasal sacs. Mysticetes, baleen whales, trade teeth for keratin, sieves, and bulk filter krill. Physiology follows. Blubber for insulation and energy, flexible chest walls, and collapsible lungs for deep dives, bradycardia, and blood shunts to ration oxygen, enormous oxygen stores in blood and muscle. A breaching whale is a land mammal, rewritten for water, ankles remembered in vestigial bones, hips retired, hearing and breath redesigned, proof that evolution can pivot entire body plans when a good gradient, food plus space, beckons. Horses tell a climate story with their feet. The dawn horse, Eohippus, was fox terrier small, a forest browser, stepping lightly on multiple toes. As woodlands yielded to open grasslands, speed beat delicacy. Toes fused into shock-absorbing hooves. Teeth grew high-crowned to grind tough, silica-rich grasses. Bodies grew larger to flee across open country. When a mare thunders across a field today, her stride is the fossil of a landscape change. Toes turn to springs because trees turn to horizon. For sheer scale, nothing beats the blue whale, the largest animal Earth has ever hosted, larger than any dinosaur. Stretching over 30 meters and weighing up to 200 tons, it moves with improbable grace and feeds on tiny krill by the million, strained through baleen like a cathedral-sized sieve. Its heart is roughly the size of a small car. Its voice travels across ocean basins in infrasound murmurs other whales can hear far away. That the biggest creature survives on some of the smallest is one of biology's neatest jokes, and a reminder that gigantic often runs on microscopic. Insects wrote the field guide to survival. Dragonflies, superb pilots with 4 independent wings, dominated Carboniferous skies when oxygen ran high. They fly now, with nearly the same design. Silverfish scuttle through our cupboards much as their ancestors scuttled through primeval leaf litter. Cockroaches' unloved roommates have shrugged off mass extinctions with minimal edits. Living fossil is an imperfect phrase, but the point holds. Some body plans are so good that evolution's job is routine maintenance. Earth's timeline has at least 5 catastrophic punctuation marks. The end Permian die-off wiped out most life. An asteroid 66 million years ago ended the non-avian dinosaurs' reign. Each calamity reset ecosystems and opened space for the survivors to invent new forms. Reefs rebuilt with different architects, forests reassembled with fresh cast lists, mammals scaled up from shrew-sized night runners to a gallery that includes elephants, whales, and us. Extinction events reveal both fragility and ferocity. Life stumbles, then sprints. Antarctica keeps receipts for a greener era. Today, it's a frozen desert, all sastrugi and blue ice, but cores from ancient soils and lake beds preserve pollen, spores, and fragments of beach relatives, ferns, and conifers, evidence of temperate forests where glaciers now grind rock. Some of these remnants retain recoverable DNA, molecular postcards from warm epochs. These aren't seeds waiting to sprout. They're archives that let us read how continents, climates, and biospheres pivoted through time. Our genomes hold fossils of a different kind, ancient viruses that joined the family library. Endogenous retroviruses slipped their genes into our ancestors' germ cells. Most are now broken or silenced, but collectively, they account for about 8% of human DNA. The plot twist is that some were recruited for new jobs. Genes, derived from viral envelopes, help form the placenta, fusing cells into a living interface that allows nutrient exchange between parent and fetus. We are, in part, built from old invasions, proof that life is a relentless recycler, turning yesterday's threat into today's tool. Step back and a pattern sharpens. Some lineages sprinted into novelty, feathers into flight, ankles into flukes, while others practiced the art of staying the course, crocodile style. Catastrophes pruned the tree but didn't fell it. Recovery rewrote the canopy. Cold deserts once wore forests and saved the receipts in ice. Even our cells keep minutes from ancient skirmishes in their code. The past isn't a museum behind glass. It's a toolbox on the bench. Every robin on a wire, every croc in the reeds, every blue whale's heartbeat says the same thing in different accents. Evolution is opportunistic, resilient, and endlessly inventive. Where the world shifts, life learns, sometimes by changing everything, sometimes by changing almost nothing at all. Every breath you take is a reunion with the planet. Inhaling is not just oxygen intake, it's participation in a planetary exchange that never stops. Each breath moves roughly 10 to the power of 22 gas molecules across about 70 square meters of lung surface, trading with blood in 300 million alveoli. The air around you is a mosaic assembled by forests, oceans, volcanoes, soils, fires, and living bodies. Winds mix the lower atmosphere in months, so molecules from deserts, estuaries, and city streets arrive in rapid rotation. Carbon atoms you exhale today once stiffened a fern frond, flowed through a hummingbird's chest, settled in limestone shells, or circulated in the torso of a dinosaur. Oxygen you draw in may have been split from water by a leaf last week, or minted by a phytoplankton bloom months ago, then ferried round the globe before meeting your lungs. Water vapor you breathe out will drift, condense into cloud, fall as rain, seep through root hairs, reappear in sap, nectar, or fruit, and someday re-enter the breath of something wild. Even trace gases isoprene from leaves, dimethyl sulfide from plankton, the tang of soil after rain join the mix you sample with every inhale. Because atoms are endlessly recycled, each breath ties you to mammoths in Pleistocene cold, to whales threading midnight seas, to moss on forgotten stones, an unbroken chain reaching billions of years. Breathing becomes more than survival. It becomes communion and calibration, your blood chemistry syncing for a moment with Earth's weather and biology. To breathe is to borrow the planet and give it back, carrying in your lungs fragments of forests, tides, fires, and time, the ongoing story of Earth, passing through you and moving on. Think of the isotopes riding along, carbon-1, 3, and carbon-1, 2, sketching photosynthesis in leaves. Oxygen-1, 8, and oxygen-1, 6, marking the memory of cloud heights and temperatures. Argon, inert and ancient, a quiet witness from deep time. Red blood cells pick up O2, offload CO2, and repeat the loop to 250,000 times in their brief 4-month careers. Each cell is a courier in the global carbon market. Tidal breathing couples your body to planetary rhythms. Barometric changes shift how gas dissolves. Humidity alters diffusion. A storm front changes what your lungs sample. Indoors or out, you're never isolated. Ventilation pulls in the sky. Plants modulate indoor CO. Two people around you exhale their own microhistories. Even stillness is motion at this scale. The Brownian drift of molecules that once swirled in a thunderhead now cross your alveolar film in milliseconds. Exhale, and your carbon joins city air, river, fog, and the food web. Inhale, and Earth answers with a blend made everywhere at once. All life on Earth speaks one molecular language. From heat-loving microbes clinging to vent chimneys to redwoods drinking light, from beetles to blue whales, the instructions for building bodies are written with the same 4-letter alphabet of DNA. 64 codons, triplets of A, T, C, and G, mapped to 20 amino acids, plus start and stop signals. Ribosomes read this score, stitching proteins one residue at a time. The universality is practical as well as poetic. A human insulin gene works in bacteria. A jellyfish's green fluorescent protein shines in mice. Crops accept microbial traits. Cells across kingdoms parse the same syntax. There are small dialects, mitochondria, and a few microbes tweak the meaning of rare triplets, but the core grammar is shared. Degeneracy in the code adds resilience. Multiple codons specify the same amino acid, buffering mutations. Behind the code sits a deeper unity. Transcription factors, metabolic pathways, ion pumps, and ATP cycles recur from microbes to mammals. Endosymbiosis left signatures to mitochondrial DNA in animals, chloroplast DNA in plants, ancient mergers that became permanent. Horizontal gene transfer shuttles innovations among microbes. Epigenetic marks layer regulation on top of sequence, yet all of it still runs on the same letters and the same ribosomal machinery. This coherence points to a single deep origin, a common ancestor whose molecular choices became the world's default. Knowing this dissolves tidy boundaries. We are not separate kingdoms so much as branches of one sprawling family, diversifying while keeping the script. A mushroom, a minnow, an oak, and a human all run variations on the same theme. A, T, C, and G, arranged into programs for growth, repair, sensation, memory. In every genome lies the same signature, an ancient poem copied, edited, and annotated across eons, still legible in every living cell. Add the fine print. tRNAs enforce the code with wobble at the third base, granting flexibility without chaos. Promoters, enhancers, and silencers coordinate timing, turning genes on and off like instruments entering a symphony. Alternative splicing lets one gene compose many songs, post-translational tweaks, phosphorylation, glycosylation, methylation, tune proteins after they're built. Conserved genes, ribosomal RNAs, RNA polymerases, core metabolic enzymes, anchor the tree of life. We trace ancestry not by bones, but by base pairs. Even CRISPR, now a tool on lab benches, began as a microbial immune memory, another stanza in the shared language. Code usage biases. Emerge organisms prefer certain synonyms for efficiency, yet translation still lands on the same 20 amino acids. The constancy is startling. Swap readers, swap writers, the message holds. Life's diversity is a library bound in one alphabet, the differences written in sequence and timing, not in the alphabet itself. You are assembled from stardust and early fire. Before oceans and continents, stars forged elements in furious cores, helium into carbon and oxygen, onward by fusion until iron, where ordinary stellar furnaces stall. Supernovae took over, blasting those stars apart and flinging metals across space. Elsewhere, merging neutron stars, minted rarer elements, gold, iodine, platinum, in a heartbeat and scattered them like glitter. The sun formed later, in a cloud seeded by those deaths, its protoplanetary disk condensing into dust, pebbles, planetesimals, and finally, worlds. Calcium-aluminum inclusions in meteorites mark the first solids of the solar system. Chondrules record flash melt events in the nebular wind, the calcium hardening your bones, the iron ferrying oxygen through your blood, the phosphorus bridging your DNA backbone, the sodium and potassium that let neurons think, all were brewed in stellar engines and violent collisions long before the sun switched on. Hydrogen, the simplest ingredient, is older still, a relic of the universe's first minutes, now pouring through your cells as water and energy carrier. Even Earth's layered anatomy echoes cosmic sorting, heavy iron to the core, lighter silicates to mantle and crust, volatiles to oceans and air, then plate tectonics recycled rock and fed chemistry to life. To realize this is to feel humbled and expanded. You are not a visitor to the cosmos, but a local expression of it, a brief arrangement of ancient atoms trying to understand their own origin story. When you look up at night, you aren't just stargazing, you are greeting relatives and reading the archives of your body. The universe dreamed itself into atoms, atoms into chemistry, chemistry into cells, and for a while, those atoms are you. Remember that when your heart beats, it keeps time with metal, forged in stellar furnaces, a quiet metronome of cosmic history playing in a human chest. Add one more layer: lithium, beryllium, and boron, too fragile for stellar cores, were chipped into being by cosmic rays spalling heavier nuclei. Silicon and calcium came from alpha capture chains. The slow S process in aging stars built half the heavy elements grain by grain, while the rapid R process in cataclysms made the rest in seconds. Prezellar grains survive in meteorites with isotopic fingerprints, not of this solar system, but of ancestral stars, You can hold them and touch a different sun's ashes. Oceans, likely delivered in part by water-rich planetesimals, became chemistry's great solvent. Lightning, geothermal vents, and sunlight drove reactions toward the first replicators. From there, selection took over, shaping molecules into cells that learned to harvest starlight and exhale oxygen, resetting the planet and setting the stage for animals, forests, and thought. Your bones, blood, and breath are the downstream of that chain. You are, quite literally, a way for ancient fire to remember itself. And so, dear listener, our journey across Earth's wonders comes to rest. Together, we've drifted through forests and seas, deserts and mountains, wandered the deep past and the hidden present, walked beside ancient creatures and glowing worms, and listened for whales that sing across entire oceans. We've watched life stretch and adapt and endure, reshaping itself again and again. If your eyes are heavy now, let them close. Let your breath fall into an easy rhythm, like waves on a shore, like wings at dusk, like the quiet tide of life itself. Each inhale threads you to everything that has ever lived. A single strand in Earth's vast, unbroken story. When you wake, if this voyage brought you wonder, you can like, subscribe, or leave a small note. It helps this channel grow and keeps these quiet stories moving through the world. But for now, there is nothing to do. You belong to this planet, to its ancient pulse, to its unfolding mystery. Let that truth cradle you, as the sea cradles its creatures, as the earth holds all its lives. Sleep well, dream softly. Remember, you carry the tale of stars and oceans within you. Good night.